In the previous lesson, 0-5, we learned and talked about compound probabilities, and the key word in compound probabilities is the probability of A or B can occur. So the key word is or. In today's lesson, 0-6, we're going to be calculating probabilities of independent events and dependent events. And the key word here is going to be and. So I want you to focus in on those two words. How do you know when you're going to have a compound versus a non-compound or an independent dependent event? So in this lesson, we're going to find the probabilities of independent and dependent events. We're also going to use a two-way frequency table to find conditional probabilities. So we'll start off with identifying what independent events are. Now the word independent should be somewhat telling. It says if the occurrence of one event does not affect the probability of a second event occurring, then the events are called independent events. It just simply means that if you have one experiment and you do it with a second experiment, those two experiments will have no impact on each other. So the key concept here is if the two events are independent, then the probability that A and B will occur is the probability of A times probability of B. And here's where I said I wanted you to really focus in on the word. In our previous one with compound probabilities, it was the word or. Either one or the other event had to occur. Now with this one, we're saying that both events have to occur. Both A and B have to occur in this trial in order for it to be a success. So that's the big difference between these probabilities we're calculating today versus the one we did in the prior lesson. So we got to make sure that we understand what independent events are. I think it's going to be really clear when we look at this example what independent events are. And they also say down here in blue that this can be extended to 3 or more independent events. We are looking at just a rule for 2 events happening, but it can easily be expanded to 3 or more events as well. So, example number 1. A coin is tossed and a die is rolled. What is the probability that the coin lands on tails and the die rolls and lands on a 3? So, first thing we want to do is think about the word independent. If we flip a coin and then we roll a die, those two things are completely independent of each other. If I roll a head on the coin, it makes no impact on what's going to happen on the die. They're completely disjoint from each other. So we're definitely talking about independent events. So in this case, we're going to find the probability of, and I'm going to use the notation from our problem, make it applicable to it. What's the probability of getting a tails on our first experiment, and then following it with a 3 on our die? Well, in order to calculate the probability of getting a tail on the coin and a 3 on the die is calculated by taking the probability of flipping a tail and multiplying it times the probability of rolling a 3 on your number cube or your die. So the probability of tail, there's only 2 possible outcomes whenever you flip a coin, and only one of those is favorable. In our case, we want a tail. So it's 1/2. We want to take it times the probability of, we're going to roll a number cube or die. There's 6 possible sides on that cube, but only one of them is represented by a 3, so there's a probability of 1 out of 6. The probability that both of these events occur at the same time is 1 out of 12. That's how we're going to calculate the probability of independent events, whether there's 2, 3, or more events. It's fairly simple. Calculate each individual probability and then multiply them together.